Alright, for the video homework, let's first talk about the question 2. So question 2 is more like a signal processing problem. We have the input signal as x1 and a lot of noisy channel. And we denote each step of the signal as x2 and x3 and so on until xn. Also, we have some other conditions like the probability over x1 equals 0 is 0.2, probability over x1 equals 1 is 0.8, and also in this system we can find that the current output of the signal is based on the output of the last signal, right, of the last state of the signal. So we can have the conditional probability as xk plus 1 equals 0 given xk equals 0 is 0.6, and probability over xk plus 1 equals 0 given xk equals 1 is 0.3. The probability xk plus 1 equals 1 given xk 0 is 0.4. Is 0.7. So okay, that's all the condition we have right now. So let's go to the questions. The first question A, is the probability over x2 equals 1. So this is an easy question because we can separate this x2 equals 1 event into two cases. Right here we can have probability x2 equals 1, x1 equals 1, plus probability x2 equals 1, x1 equals 0, right? And with the conditional probability equation, we can turn this thing into the conditional probability as the condition we have. So it is x2 equals 1 given x1 equals 1 times p, x1 equals 1 plus x2 equals 1 given x1 equals 0 times p, x1 equals 0. So this is the probability over xk plus 1 equals 0 and the xk equals 1 given xk equals 1. And this is the xk plus 1 equals 0 given xk equals 0. So we can take all the value of the probability into this equation as 0.7 times 0.8 plus 0.4 times 0.2. So the calculation is easy. We can have 0.64 as the answer to question A. And then we jump to question B. The question B is to find the probability over x3 equals 1. So basically it's the same as the question A, but it's one step more, right? So if we want to find the probability over x3 equals 1, we have to find the conditional probability for x3 equals 1 given the output of x2, right? So what we have right now is this probability x3 equals 1 given x2 equals 1 times x2 equals 1 plus probability over x3 equals 1 given x2 equals 0 times probability x2 equals 0. And for all the probability in this equation, we can find this value and this value in the condition, right? In the xk plus 1 and xk condition. So, and also this one is the answer to the question A. So what we need right now is the probability over x2 equals 0. So it's totally the same to question A. So let's skip to the equation. We have is probability x2 equals 0 given x1 equals 1 times p x1 equals 1 plus probability over x2 equals 0 given x1 equals 0 and times probability x1 equals 0. So and it's easy. It's 0.3 times 0.8 plus 0.6 times 0.2. And the answer is 0.36. So the probability over x2 equals 0 is 0.36. And then we have all the probability in this equation. So we can have the answer to the question B. x3 equals 1 equals to this one is the xk plus 1 equals 1 given xk equals 1. So it's 0.7, yeah. 0.7 times probability over x2 equals 1, and which is the answer right here, 0.64 plus this is the probability over xk plus 1 equals 1 and xk equals 0. So it's 0.4, yeah, 0.4 times probability over x2 equals 0 is 0.36 as we just calculated. So the answer is easy, 0.592. So this is the answer to question B. Okay, 2 questions down, and we still have 2 more questions. Let's go to question C. So question C is a little bit more tricky. Yeah, we need to find the probability over x1 equals 0 given x3 equals 1. So as we may find that this is the, how to put it, this is a reversed order, right? Because x3 is the step after the x1. So what we usually or what is easy to get is the probability over x3 equals 1 given x1 equals 0. Right? This is the so-called right order. Yeah. So how do we transform this reversed order to this right order? Yeah, we can use the probability, the conditional probability equation here. Yeah, because we have probability over x1 equals 0 given x3 equals 1 is equals to probability over x3 1 and probability x1 equals 0 and x3 equals 1, right? This is the end condition, it's not the given condition. So what we have is right here, and we can turn this thing into another conditional probability equation. Yeah, so we can have the right order, with this step. It's x3 1 given x1 equals 0 times probability x1 equals 0, right? And also this one is the same, probability over x3 equals 1. So this is easy. This value we have had right now, and this value is the answer to question B. So what we need is the probability over x3 equals 1 and given x1 equals 0. Okay, so let's make it easier, because the x3, the output of x3 and the output of x1 is confirmed in this event right now. So what we can change, or the different cases, they all depend on the output of x2. So there are 2 different cases. The first one is probability over x3 equals 1 given x2 equals 1 times probability x2 equals 1 given x1 equals 0 plus probability x3 equals 1 given x2 equals 0 times probability x2 equals 0 given x1 equals 0. So, and these are easy, right? Because this is xk plus 1 equals 1 given xk equals 1, it's 0.7. This is the probability over xk plus 1 equals 1 and xk equals 0, so it's 0.4 plus, yeah, it's all the same, so I'll just skip to the value part. You have to get to the calculation part, so it's 0.4 times 0.6. So finally we can have the 0.52 as the probability over x3 equals 1 given x1 equals 0. So right now we can take this value into this equation here. So the answer to the question C, we can have the final answer. It's 0.52 times the probability over x1 equals 0, it's 0.2. And the answer to question B, it's 0.592. Right, so and the final answer is 0.176. Okay, one last question. Question D, we want to find the probability over xn equals 0 when n is close to the infinite. So maybe this makes all the students confused because we don't know how it looks like or how the probability will be, when the n is close to infinite. But at that time, we can know that when n is close to infinite, we can have xn close to xn plus 1, right? So what we can have in the probability part is that probability over xn equals 0 is also close to probability xn plus 1 equals 0. And the probability xn equals 1 is also close to probability xn plus 1 equals 1. Right? This is a natural thing, yeah, because when the n is super large, the signal would be almost the same, yeah, they would not change a lot. So with this two equation right here, we can have the probability over xn equals 0. So let's denote the probability over xn equals 0. It's a, and the probability over xn equals 1 is 1 minus a, right? Because there has to be, in these two cases, there is no other output of xn. There's no other possible output of xn. So we can make some equations right here, as we all know. For probability xn plus 1 equals 0, it equals to probability xn plus 1 equals 0, xn equals 1 times probability xn equals 1 plus probability xn plus 1 equals 0 given xn equals 0 times probability xn equals 0. Alright, so this is the same to the former questions. We can have the xk plus 1 equals 0 given xk equals 1. The probability is 0.3, right? 0.3 times 1 minus a plus 0.6 times a. So, and also the probability over xn plus 1 equals 0. Yeah, we're gonna have A. So with this equation here, we can have the answer A is 3/7, right? So the limit n is close to infinite, probability over xn equals 0 is 3/7. Okay, that's all about the problem 2. Okay, thank you.